Hello everyone, welcome back, and today I'm solving another LeetCode problem. It's called Peak Index and the Mountain Array. Funny enough, I solved a very similar problem. It's not similar, but it's just related to this one. So I was determining whether the array was a mountain array, and it was an easy problem, but still it helped me a lot. Uh, the task itself here, I find it very confusing, so I'm just going to explain it with my own words. First, what is a mountain array? A mountain array, it consists of three elements here. So let me show you. Let me give you an example of a mountain array. So we have this, and let's say this. So this is a valid mountain array. And by the way, every given array here is a valid mountain array. It's mandatory, so we don't need to check it, check its validity. So that's what I mean. So what are the two parts? Well, this is the first part. This is the first part, 0 and 1. This first part, it comes before the mountain's peak and is strictly increasing. Then the second part is you, uh, as you can see, it's the largest element in the array. It's called the mountain's peak. And then the last part is the part that is strictly decreasing. So what we are asked for is the index of the mountain's peak. So here it would be 2. Um, So yeah, and as soon as I read this line, you must solve it in O log of array length time complexity. Almost like immediately, binary search came to my mind. So I'm gonna be using binary search here. And if you're not familiar with binary search, uh, I highly recommend you solving the binary search problem first, because otherwise it's just like it's impossible to understand everything here. And it doesn't make any sense. This is just like a different version of it, I would say. So you got to learn the initial binary search. So as we usually do, we're gonna initialize two pointers. The first one is 0. The last one is the length of the array minus 1. Then we're going to use while loop, as we usually do. And then we initialize the middle. So the middle equals L plus R divided by 2. Now, this is the point where things got complicated. This is the point where when I realized that the statements are different. So in the binary search problem and the easy one, we just compare the middle, like right? We got the middle. The array is sorted, and we just compare the middle with the target, and based on that, we move the pointers. But here, the array is not sorted, so what I was, it took me a while actually, and I came up with this. So what if we check if the element on the right of the left pointer is larger, and we check whether the element on the left of the right pointer is also larger. So it might be confusing, but I'll show you why it works. So uh, so let's start. So if array middle, so basically I explained it with like left of the right pointer and right of the left pointer, but it's just gonna be middle. So if this is, so basically like we just check whether the element on the right of the middle whether it's larger, right? And then we move the left pointer there if it's larger, because it's obviously just not the peak, not the mountain's peak. So if array mid is less than array mid plus 1, we move the left pointer, we move it to the right. So we set it to the middle. Then elif, what can also happen, as I mentioned, if array mid is less than array mid minus 1, so we're going to move the right pointer to the left. So if this is the case, we move the right pointer to the left, right? So, and otherwise, what does it mean? It means that the middle equals to the mountain's peak. So we can just return it. Return mid. And I believe this is it. Let's find out. And I guess it does work, so let's submit the solution. And yep, it does work. As you can see, the efficiency might not be perfect, but it is working. It's not horrible. So, so thank you guys for watching, and hopefully see you in the next video.